Hey guys, so we're going to go ahead and try this question where, given this table of values, we're going to determine the different transformations that have occurred to this parent graph. So P of t is just like x as a variable, and that will change P of t to be Vinny, V of t, or P of t over into H of t, so Hector. And so we need to think of some math transformations that would do that. We're going to write the equations for both of those transformed kid graphs, quote unquote. So again, the t variables, just like x, and these different numbers help line things up, that if we go and put that number in to the parent, this is the outcome, the output. So 0 leads to 0, and 4 leads to 4, and 5 leads to 5, and 10 leads to 10, -9 leads to 9, and -8 leads to 8. Okay? This is like starting value, ending value, and these would create coordinates. The transformed graph, this kid graph, Vinny, Vinny doesn't end up with 9 like its parent. It's actually at 18. And it's not 8 like its parent, it's 16. But it does have 0 to 0, so that is an unchanged value. 4 as a parent is now 8 as a kid. 5 as a parent is 10 as a kid. And so you can start to see that all of these values are twice as big. And that is the key. Okay, if you know that it's twice as big as P of t, then you know that you have to take this times by 2 every single time. And so what we do is we're going to write V of t equals, you always focus on the kid first, how did you get there? And we are going to be changing the parent, P of t. What did we do to all of these parent values? So all of these P of t values got multiplied by 2. And where does multiplying go in terms of transformations? It would go in the front. So 2 times P of t. That will be stretching all of the heights. So stretching the heights doubles how far up you would have to go unless you are actually at 0, because 0 times 2 still gives you that amount. Okay? The next one is maybe a little bit trickier. Henry is not as easy to figure out how he was made. So when the parent is 9, Henry is at 20. When the parent is 8, Henry is 18. 0 is 2, so not the same there. And then when it's 4, we're 10, 5, and 12, and so on and so forth. And so if you kind of look, there's not a way to multiply and get here, at least not just by multiplying. You can't just add. So if you tried to add 11 to end up over at Hector, you can't add 11 and end up here. Okay, 11 more would be, 19. Adding 11 to 0 puts you at 11, not at 2. And so it's not just adding, it's not just multiplying. What you have to sometimes do is look for relationships between the kids. Siblings sometimes can look very similar, and you can tell that they're siblings because they share certain traits. So if you look from Vinny to Hector, or Henry, whoever this is, 18 and 20, 16 and 18, 0 and 2, 8 and 10, 10 and 12, 20 to 22 would all be V of t, these numbers, plus 2. But see, here's the issue. We can't talk about Hector in terms of his brother. We have to go all the way back to this parent function. And so remember, this Victor set of answers was 2 times the parent. And so instead of having Victor here, we could have 2 times P of t. And so double the parent's number, add 2 to it, is how you would get the resulting values every single time. 8 times 2 is 16, 16 plus 2 is how you would end up over there. 0 times 2 is 0, 0 plus 2 is how you would end up over there. And that is the consistent rule that gets these end results for Hector. So how do we write Hector's equation? Well, H of t equals, it is the same thing as Vinny, so this is Vinny 2 times the parent. And then what do we have to do to those values? We added 2 at the end. All right, that can be a tricky thing, and sometimes using the kids and comparing the siblings together can help get you past just going straight here to the final result. That can be tricky. So hopefully that video helped, and if you have questions, you just gotta ask. Thanks.